This week we'll learn how to add some interactivity to our app by using signals and slots. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to keep exploring using Qt to create a graphical user interface for a program. And we're going to talk about signals and slots, which is one of the fundamental concepts to Qt programming. If you've done anything with GUI programming before, the idea of a callback function may be familiar to you, and this is sort of the Qt version of that. A signal is something that's emitted by any widget when something happens to it. It could be emitted by a value change, or by a click, or a mouse over, or any other number of events. All of these signals get put in a signal queue to be processed by your main application loop. If that signal is connected to a slot, then that slot will be called or activated when that signal is present. So for example, if we want to have, when we push the calculation button, it run a calculation and output the result, then we're going to connect the signal of click from the button to the slot of a calculation function. And really, in PyQt, or PySide2 rather, the slot can be any Python function. Though as you'll see, there are some tricks that we have to do to pass it additional arguments. So our goal for this week is going to be when we click the calculate button for a calculate function to run and actually calculate the wet bulb temperature. So to do that, we know we're going to have to import some more functionality. Up here at the top of our script, we're actually going to import metpy.calc as mpcalc. From metpy.units, we're going to import the units registry because we know we need units for united calculation, which is what metpy depends on. Now we have to do some cleanup from last week. So last week, to just get widgets on the screen that we could see, we could understand what they were, we just created this list of widgets, but none of these have any kind of handle. I don't have any way to talk to them easily afterwards other than indexing into this widget list, which would quickly get pretty confusing. Now, certainly you could have a dictionary and have a name, but for a few widgets, we generally just create instances of them and name them. So for example, I'm going to create our pressure as a Q double spin box, our temperature as a Q double spin box, our dew point as a Q double spin box. The result is going to be that QLCD number, and the calculate button is going to be our Q push button that says calculate on it. Now our widgets list, I'm going to still have it so that I can add widgets to the layout easily, but it's now going to consist of those handles, pressure, temperature, dew point, result, and calculate button. So a pretty subtle difference, but just some cleanup that we need to do. All right, so before we connect a signal to a slot, we need to write the slot function. And generally I like to do that first, and then I can go back and connect it later instead of trying to connect it and forgetting to write it and then trying to track that down. We're going to write our slot function as a method in this class that we've created. So we use def just like any other function, calculate wet bulb. But remember, it needs to take self because it is a method of a class. All right, so down in the calculate function, I'm going to just first do some really simple printing of wet bulb calc called with an exclamation point there so we know if this is working. So now I've created a slot and I need to go connect the signal to it. There are a couple ways to do this. I'm going to show you the easiest and most Pythonic way that PySide2 has. So back up here in our dunder init method, I'm going to comment that I'm connecting signals and slots. Our calculate button, when it's clicked, we're going to connect that signal to the slot of calculate wet bulb. Notice I don't put parentheses after it. I'm passing the function as an object. I'm not calling it. So let's save this and run our app. So in the terminal, we're calling our app with the Python interpreter. We run it and we see calculate wet bulb is not defined. Okay, well, we know that our function is called calculate wet bulb. Calculate wet bulb. We don't see any misspellings. Yes, remember, we're in a class. So we have to do self dot. This is a method of the class of self. Now let's run our application again. All right, we have our application up, and when I click the calculate button, we see wet bulb calc called. And the more times I click it, the more times that shows up. So we think we're most of the way there. Let's go ahead and implement the calculation functionality. So we'll get rid of our print statement, and we'll calculate the wet bulb temperature using mpcalc.wetBulbTemperature. We know that takes pressure, temperature, and dew point, but remember, these are united. So the first way that we might approach this is to take our pressure object of our Q double spin box, the instance of that double spin box, and call its value method to get the value, multiply it by units of hectopascals, and we can do the same for everything else. So pressure, temperature, dot value, units, degrees Celsius, and dew point, dot value, times units of degree Celsius. Okay, so we're going to take those values from our Q double spin boxes, pass them to MetPy's wet bulb temperature, and then we will print the wet bulb out. So let's try running this code and see what happens. Clear our terminal here. We get our application, and when I click calculate, we see that we get a name error. It says the name pressure is not defined. So if we look at our code, why is pressure not defined? So while that object exists, the method calculate wet bulb has no way to access it. Now you could certainly do some hacky things to get around this, but the most accepted way to pass additional arguments to a slot function is to use a lambda in our connect. So it's going to look something like this. In connect, we're going to use lambda, self, calculate wet bulb. That part's going to stay just the same. But then we are going to actually pass to calculate wet bulb these things, our pressure, dot value, our temperature, dot value, and our dew point, dot value. And we can go ahead and do some wrapping just to make this a little more readable. Okay, so now that's going to pass those things to our function. The lambda is how we're creating that function object instead of calling the function immediately. So it's going to pass a pressure, a temperature, and a dew point. Now we replace these with pressure, temperature, and TD dew point. All right, great. So let's try that. We get our application, we click calculate, and right now we're just seeing a message that says, well, there's a math error. We might expect that because we have all zeros here. So let's try putting some real numbers in. What about 1,012 millibars? I can't enter anything past 10. Well, there are some defaults to limits on Q double spin boxes. And in fact, as a programmer, it's your responsibility to make sure your user can only enter values that make sense. So we need to go in and specify some limits on our double spin boxes. So for pressure, I'm going to say the minimum pressure has to be more than 0. And the maximum pressure, let's go with something very high, say 2,000 millibars. We could argue about what that limit should be, but I know that we're not going to be dealing with any pressure over 2,000 millibars, certainly. Temperature, I'm going to specify a minimum and a maximum of plus minus 100. And we're going to carry that over to dew point as well. All right, let's save that, run our application. Okay, so now I can enter a larger value of 1012. I can enter 20 for temperature. I can enter 18 for dew point. Then click calculate. And now we see we have a wet bulb temperature of 18.638 degrees Celsius. Now we still need to do some more processing, maybe tune up our interface some. Definitely labels would help, because right now nobody but us knows what's supposed to go in these magic boxes or what we're calculating. And we need to put that output on the screen instead of just here in the terminal. We probably also want to do something about the behavior of the app resizing, make sure that it starts at a reasonable size. So we'll continue to tune up our application on next week's MetPy Monday.